All right, so I want to do a little bit of section 0.8 and a little bit of section 0.9. We already covered the main point of section 0.8, like I mentioned before, but I'll just go over it again. Rational expressions. So your exercises are 1, 7, 19, 21, and 25. So the main example from this section, which I already did in the equation section, was where we had a fraction in our equation and we ended up with the surprise x equals 2 that wasn't actually a solution. So that was kind of the big takeaway from this section. But I just wanted to quickly give you, and I said that at the time that I was kind of spoiling a later section, but I want to just quickly give you something to chew on for section 0.8, and then I'll move on to section 0.9. So let's do one quick example, and that is solve for x. Actually, I can show you precisely the example I'm talking about that we already did, and that would have been, I think I did it in section 0.3. Yeah, that was this example. This is the main example for the section that I'm covering now. But so we already kind of did that in section 0.3, but that's okay. I want to do another example. So let's solve for x. 1 over x plus 1/4 equals 1/3. So if you can do this in your head, that's great. But if you can't, I just want to go through this kind of slowly and intentionally. Expressions like this, or equations like this, come up a lot when you're solving really basic circuit theory equations, because you have a lot of things, a lot of relationships are expressed in 1 over x plus 1 over y sort of ways, particularly like resistance and current and stuff. So let's try to solve this. What I want to do is, of course, get x by itself. So I'm going to subtract 1/4 from both sides. So I've got 1 over x plus 1/4 equals 1/3. I'm going to subtract 1/4 from both sides. So now on this right-hand side, I'm going to have a difference of fractions. And a lot of you are great at fractions, but some of you probably aren't. So I want to go a little bit slowly through how to deal with 1/3 minus 1/4. So I've got 1 over x on the left-hand side. And on the right-hand side, I've got 1/3, and I'm going to leave some space. And then I've got minus 1/4. So how do I put these two things together? Well, I want to find a common denominator. So the least common multiple, of 3 and 4 is going to be 12. And that is the kind of thing that if it wasn't obvious to you that 12 was the least common multiple of 3 and 4, you probably need to review some intermediate fractions stuff. You're going to be thinking about things like greatest common divisor or greatest common denominator or things like that. Least common multiple, least common denominator. Least common denominator, not greatest common denominator. So they have a lowest common multiple of 12, and so that means that I want to make both of these fractions over 12. So in order to make this 3 over 12, I'm going to multiply it by 4 over 4. And in order to make this 4 over 12, I'm going to multiply it by 3 over 3. Now you notice I'm only messing with the right-hand side of this equation, which would normally be bad, but it's okay because I'm multiplying by 1, because 4 over 4, this is 1, and this is 1. So I'm not actually changing the value of the right-hand side. I'm just changing how it looks. When I carry out these multiplications, I'm going to get 4 over 12 minus 3 over 12, and that difference is 1/12. So my final answer is x equals 1 over 12. Now this is significantly simpler than the main question for this section that we've already covered, but I just wanted you to kind of see some stuff about rational expressions. So this is, sort of the next step up from polynomials. So this is polynomials potentially in the numerator and in the denominator of a fraction. So now I want to move on to section 0.9. And 0.9 is going to be radicals and equations. Again, this is going to be just a quick dip into this. So suggested exercises are 1, 7, 15, 27, and 33. I almost skipped this section, and I thought, well, why don't I just go through it really quickly, So I'm just going to give you a brief touch on these. So I want to remind you about multiple roots when we're solving equations with multiple roots. And I also wanted to remind you about conjugation. I've already said I'm not going to do much with conjugation in this class, but it's good to be reminded about it. So first, let's do a little thing about multiple roots. Now we've already said the square root of 4 is 2, not plus or minus 2. But the solution to x squared equals 4 is x equals plus or minus 2. So here, when I'm taking the square root of a number, this is a square root function. It takes one input, it gives me one output. When I'm solving an equation, I'm just looking for every value of x that makes this equation true. Now, whenever I have an even number, so 2 is even here, I'm going to need this plus or minus sign. All right, this little plus or minus sign right here. If I have an odd exponent, though, I won't need that. So another quick example is going to be if I look at the cube root, that was not a great job of drawing that. If I look at the cube root of 27, this is equal to 3. And now if I try to solve the equation x cubed equals 27, this has solution x equals 3, not plus or minus 3, okay? The reason that this has plus or minus 2 is because positive 2 squared is 4, and negative 2 squared is 4. So if I plug in either plus or minus 2 into here, I'm going to get positive 4 out. But notice, while x equals 3 is a solution, so 3 cubed is 27. That's 3 times 3 times 3 is 9 times 3, which is 27. Negative 3 cubed would be negative 27. So there's no need for plus or minus here. Okay, so the last thing that I wanted to talk about, and this is in section 0.9, is rationalizing or conjugation. So if I have something like the square root of x plus or minus the square root of y, sometimes I do something called multiplying by the conjugate or rationalizing, which is multiplying by the same thing, square root of x, square root of y, except with this sign here flipped. So if I have plus minus, then here I'll do minus plus. So what that means, this plus minus and minus plus notation, you've probably seen this before, you may not have seen this. So what minus plus means is that somewhere else there's a plus minus, and here we use the opposite sign. Okay, so let's do a quick example of this. So a quick example, rationalize the denominator. Now, I already told you I'm not planning to do a whole bunch of this, but just for some practice. So let's do 240 over square root of 3 plus the square root of 4. Okay, like I said, I'm not planning to do a bunch of this in this class, but I thought, you should at least see it because it is a useful technique. Sometimes you need to clean things out. I will probably not be asking for it too often. So solution, we're going to multiply 240 over root 3 plus root 4 by its conjugate, by the conjugate of the denominator. So here, if I've got root 3 plus root 4, the conjugate is going to be the same thing, but with the opposite sign in the middle. So it'll be root 3 minus root 4. Now this is an expression, and I can't just go multiplying the bottom of a fraction by something without also multiplying the top of the fraction by the same thing. Root 3 minus root 4. Now I know I normally just start with the problem statement here and then I do this on another line, but since all I'm doing is multiplying, I went on ahead and did it right here. Now the way this works is the numerator is basically done. We've got 240 times this root 3 minus root 4, whatever that is. I don't really care what that is. It is what it is. Now the bottom, I'm going to FOIL this out. And this is going to take a little bit longer than, might seem strictly necessary, but this is just so you just remember how this works. So first, I do root 3 times root 3, outer, root 3 times negative root 4, so minus root 3 times root 4, inner, root 4 times root 3, so plus root 4 times root 3, and then last, root 4 times a negative root 4, so I've got minus root 4 times root 4. Okay, now I know I could take the square root of 4 here, but I'm intentionally not doing that because I don't actually care what the square root of 4 is for this particular step. The big thing to notice is that this and this will cancel each other out. the square root of 3 times the square root of 4 is the same as the square root of 4 times the square root of 3. So these two, I'm subtracting the same amount that I'm adding in, and those go away. Now I'm going to simplify, and I have 240 times the square root of 3 minus the square root of 4 over, well, square root of 3 times the square root of 3 is 3. Square root of 4 times the square root of 4 is 4. So I've got 3. Well, those canceled out, but I can't forget about this minus sign. 3 minus 4. Now, here I've noticed that the denominator is rationalized. That is, there are no radicals in the denominator. That's kind of a, so rationalizing is a funny term in that sense, but we won't go into it too much. Okay, so I've got 240 times root 3 minus root 4 over 3 minus 4, which is negative 1. So this is just negative 240 times root 3 minus root 4. Or if I wanted to be really specific, I could say this is negative 240 times root 3 minus 2. And I could even say this is 240 times 2 minus root 3. Okay, really pretty much once you get here, you're probably fine. But this would be like a complete full final answer. Okay, I hope that made some sense. Talk to you soon.